Hi, this video is on understanding the graphs and how to make a new graph with basic steps on walkthrough, how to read a graph and how to understand different components of a graph, and also how to make a graph in a scientific manner. To start, let's have a look at a generic graph and understand the different parts of the graph, so it's easier for you to read any new graphs that you're going to encounter. Okay, first, every graph has a title which by default should be a self-explanatory component. It should give away the experiment or the data that is being presented. In this case, it's a cytotoxicity assay of a particular nanoparticle that is being synthesized. That's a chart title. Then you have axis title. Each graph usually contains at least minimum two variables, one x-axis and one y-axis. The title should say what is this y-axis and what is this x-axis. It should clearly convey in this particular graph, you have concentration of the nanoparticle in the x-axis and the percentage of cell viability on the y-axis. So in this case, concentration of the nanoparticle is a independent variable and the percentage viability of the cells is a dependent variable which changes according to the concentration of the nanoparticle used, which we will see a little detail later on what is independent and dependent variable. Then you will have a legend. If you are comparing multiple series of data, this is data series, then you definitely need a legend which conveys what are the variables or the series that you are presenting and what is the color code or the pattern code for it. Every biological experiment has to be repeated at least 3 times. It's called as triplicates or duplicates. When you repeat it 2 times, it's called as duplicates. When you repeat it 3 times, it's called as triplicates. Every biological or every experiment has to be repeated at least thrice or twice in order to show reproducibility or the consistency of the result. So that consistency should be represented in the form of error bar, which is usually the standard deviation of all the 3 values. Okay, so you should at least do 3 times so that you can calculate a standard deviation. So the error bar in the graph usually represents the standard deviation of this particular value. And what is the value? The value is the average of the 3 repeats, but the error bar is the standard deviation between or among the 3 different repeats. So this is what you call it. Data point means the actual point at which you are seeing the result. For example, in the x-axis of 1.6 microgram per ml concentration, the cells demonstrated a total of 100% viability. The 100% is nothing but an average. That is your data point. When you are saying here, the data point is that it is 100%, which is an average. However, you have repeated the experiment 3 times. So when you take an average of that, it is coming to 100%, but that means the standard deviation will be plus or minus 2% or plus or minus 3%. There will be some deviation, that is called standard deviation. That will be represented in the form of error bar. Standard deviation is represented in the form of error bar. Next comes the data series. What is the data series? In this, you have 2 different cell lines. The effect of the nanoparticles on cell viability of 2 different cell lines, HCT 115 cell line, which is a colon cancer cell line, and Vero cell line, which is a non-cancerous cell line. So you are trying to assess or compare the impact of the gold nanoparticles on two different cell lines at the same concentration. So as you can see here, the blue cell lines are having much less viability compared to the red ones, which is the Vero cell lines. So you are comparing the effect of the same nanoparticle at the same concentration on two different cell lines. What does this mean? This means that the particular nanoparticle is having more toxic effect on HCT115, which is a cancerous cell line, compared to the Vero, which is a non-cancerous cell line. So this is how you read the legend. The legend will tell you what are all the different data series. I am giving two series of data. One, the effect of nanoparticles on HCT115 cell lines, that is one data series, and the effect of the nanoparticles on Vero cell lines, that is second data series. And both the data series are represented in different color so that it can be easily read. To understand what does this color mean, we are giving this legend. So that explains what is data point and data series. But when you're talking about data, you have to talk about what are the types of data that you have, right? So first, you have the major categories is independent data or independent variable, dependent variable, control variable, and confounding variable. What is independent and dependent? Let's have an understanding in this using this graph. In this particular experiment, you are fixing the values of the concentration of the nanoparticle. That is, it is a fixed value and it does not depend. The concentration of the drug does not depend on any other variable. You are fixing it so that you can test at various dilution. Either you are doing a 10 times dilution, for example 100 micrograms, 10 micrograms, 1 microgram, 0.01 microgram, etc. Or you are doing a double dilution, like in this case, starting with 400 microgram, going 200, 100, 50, 25 and so on. So this is called as a double dilution. Or when you do a serial dilution, you can also do a 10 times dilution, say 10 to the power minus 1, 10 to the power minus 2, 10 to the power minus 3, etc. Right? So that is a fixed series of value which you are deciding on a trial and error basis or based on previous experiments or literature evidences. You are deciding that dilutions that you're going to test. That means the experiment is going to test the effect of the different concentrations or of the particular drug on some variable. So this concentration of the drug is independent of anything. So it usually goes on the x-axis. The examples of this include age of the patient, the treatment types that you are giving, what are the dose of the drug that you are giving to a patient. Correct? And what is a dependent variable? Means the independent variable conveys a certain drug dosage or the type of treatment. So in this case, dosage of the drug, that is the nanoparticles at different dose. Now in response to this different dose, what is the response you are receiving from the cells, or what is the particular parameter that you are measuring in the biological experiment is called as a dependent variable. It's called as a dependent variable. So independent variable is something that says this is the parameters that I'm testing. What is the impact of this particular conditions? It can be dosage, different dosage, or it can be different types, or it can be different geography, Indian population, Asian population, Caucasian population, African population, etc. Or it can be on age, the same effect of the drug on different age groups of the people, etc. So that comes on the independent category, and always the independent variable always comes under the x-axis, and the response you get for that independent variable is called as a dependent variable, because the percentage of viability of the cell completely depends on the concentration of the drug. That's why it's called as a dependent variable. I'll repeat, the percentage viability of the cells depend on how much drug you are treating them with. So the dependent variable can easily be understood if that particular variable's difference or changes in that variable completely depends on another variable, then it is called as a dependent variable. In this particular case, concentration of the nanoparticles does not depend on anything. You are deciding it based on a trial and error, or you are deciding it based on a literature evidence. But the percentage of cell viability completely depends on the dosage of the drug. That's why that's a dependent variable. So dependent variable always goes on the y-axis and independent variable always goes on the x-axis. There are other things such as control variable. For example, when the experiment is going on, you are keeping one thing as constant. The room temperature is always constant. In this particular case, the incubator temperature is always 37 degrees Celsius. So that's a constant variable. The temperature of the incubator or this room temperature is always a control variable. Confounding variable is a variable that affects both the viability and the dosage. For example, if your independent variable is the hours of sleep, depending on the hours of sleep that you get, you will be more active. For example, if you get a 6 hours of sleep, you will be able to do more productive work. If you are having 2 hours of sleep, then you will be very less productive. Your working capacity will come down. But imagine you are getting a 6 hours of sleep, but you are very much stressed. That will still affect your productivity. And when you are stressed, definitely that person or the patient is not going to be able to sleep for 6 hours. So stress is something, a third parameter or a third variable which can influence both dependent variable and independent variable. That is called as a confounding variable, a factor that affects both independent and dependent variable. Is that clear? Then,
Yes, sir.
then you have another type of data or variables, categorical and numerical. What is categorical? The before example I quoted, if you are trying to understand the effect of a drug on Asian population, Asian population, African population and Caucasian population. Asian, Caucasian and African, these are not numbers, these are categories. For example, let's say you are trying to understand the effect of drug on below 10 years age, above 10 years, below 20 years, 20 to 30 years, 30 to 40 years. Although these are numbers, you cannot say 1 to 10 age is a number, is not a numerical data, that is a category. 1 to 10 is a group, it's a category. Although it is the value is number, it is not a numerical data, it's a categorical data. What is the numerical data? For example, you are saying year 2019, 2020, 2021, 2022. That is numerical data. Dosage of drugs, 100 microgram, 200 microgram, 300 microgram. There is a continuity in that data. That is called as numerical data. Categorical means you have a bin value, meaning it is either has a category like 1 to 10 or 10 to 20, 20 to 30. That's a bin area, that's a category. Or you have names such as Lokesh, Ramesh, Suresh, etc. Or you have African, Indian, Caucasian, etc. That is categorical and numerical. These are the primary types of data that you need to understand. So you know when you are plotting a graph, you are putting the right category, right data on the right axis. So why did I mention this? A categorical data always is represented in the x-axis. Whether you are also looking at it whether it is a independent or dependent, but you should also make sure that if it is a categorical data, it always goes on the x-axis. So a categorical data is always an independent data. Asian, African and Caucasian, that is a categorical data, and that kind of categorical data always comes on the x-axis. Whereas a numerical data can both be present in the x-axis and in the y-axis. A numerical data such as age of the participant, it can be either on the x-axis or on the y-axis. A numerical data can be both independent and dependent, but a categorical data has to be always independent. Okay. We already told you what is axis title and what is chart title in the previous graph. I already explained to you what is error bar. Error bar is nothing but it represents usually the percentage of error or the standard deviation of the particular data. Now the same information, whatever we discussed so far, it is for a 2D graph. It's a two-dimensional graph where you have only two variables, x and y. What about 3D graph? A 3D graph contains three variables, x, y and z. That is horizontal axis, vertical axis and depth axis, that is z axis. Look at this. So you have a x, you have a y and you have a z. That's the third one. So you have x-axis always has a independent variable. Yes, there is no doubt about it. There is no change. Y-axis always contains a dependent variable. Yes. And what about z-axis? What does it contain? Z-axis can contain both an independent variable or a dependent variable, depending on what you are trying to compare. You can compare sleep, number of hours of sleep, productivity percentage and stress level. So stress level is a confounding variable which can affect both independent and dependent. That can be added in the z-axis, or another independent variable can be added in the z-axis, or another dependent variable can be added in the z-axis. So usually in a three-dimensional graph you have minimum of one independent variable and you have a minimum of one independent variable and two dependent variable, or you can have two independent variable and one dependent variable. I'll repeat. In a three-dimensional graph, you can usually have minimum of one independent variable and two dependent variable, and in another example you have two independent variable and one dependent variable. I'll explain to you this graph. It makes it easy to understand. A mean temperature with standard deviation. It is representing what is the temperature over the last 1 century, right? So look at the x-axis here. This is x-axis, this is y-axis and this is z-axis. So in that particular duration, 1987 to 1996, that is a range, that's a category, that's not a number, that's a category. So a categorical value always comes on the x-axis. It is always a independent variable. It cannot be a dependent variable. So as this is a categorical value, it always comes on the x-axis, which is an independent variable. You have another variable which is the temperature that was recorded in that particular time duration. So temperature is always in a continuous range, right? So this is a numerical data and it is a dependent variable. In this particular time period, this was the temperature. So the temperature depends on the timing, that the time period, the year that it was recorded. So this is a dependent variable and this is an independent variable. And within this particular year range, you have another category, that is winter, spring and summer and autumn. This is not a continuous data, this is a categorical data. This is not a numerical, this is a categorical as it has names in it. So this particular x-axis value is further divided into 4 in the z-axis. So by looking at it, you can easily confirm that the z-axis is another independent variable. So look at this. This is the temperature that are different temperatures that are recorded, and look at the error bar. That is nothing but the standard deviation, mean standard deviation or mean fluctuation, variations in the data. In addition to this, they have also given something called as a heat map, which I'll explain to you later in the types of data or types of graph. This basically says the color of each bar represents the intensity of the data point. What is data point? Data point is nothing but the average of all the data that is recorded in that particular category. Let's look at this. In 1887 to 1896, during that year, during that time, in winter, that is another categorical value, on this during these years, that is, let's say, one decade, in all the winters you had a very low temperature which is recording up to 5 degrees Celsius or so, with a standard deviation of rising up to 10 degrees plus or minus, 5 degrees plus or minus. So it is in a blue color. Look at the spring. In the spring, you see that compared to 1987, compared to 1937, and compared to 1887, there is a huge difference. Correct? You can say that in 1987, the temperature was closing up to 15 degrees Celsius, which is represented in slight green color, slight yellowish green color. Whereas in 1887, several decades before that, you can clearly see the temperature is below 15 degrees. It is in bluish color. That means above 15 degree it is slight yellowish green, and below 15 it is bluish, light bluish. So this also helps us to, the color also helps us to understand the difference without needing to look at the exact value. By looking at the color only, you can understand the difference in the temperature. This type of color differentiation is called as a heat map. When you have a scale, color based scale next to it, this is called as a heat map, that I'll explain to you later. This is a much more complicated graph, but if you can pay close attention, what are the mistakes in this graph, that will be, you can discuss this after the video. You can pause it and try to identify what are the errors that you can see in this particular graph. One of the main problems in this graph is that visibility. I'm not able to visualize, or I'm not able to see all the data points. Several data points are hidden. For example, if you see in this particular point, I cannot see all the data points. It is hidden because of this tall graphs. Again, in the behind this particular data points, behind these values, I cannot see the data points in the back end. So when you are constructing a graph, make sure all the data points are clearly visible. That is one of the primary requirements of making a graph. So that's a major drawback in this particular graph. Look at this graph. What is the mistakes? There is no chart title or there is no axis title. So I do not understand what is this y-axis. 70, 60, 50, what is this? This could be anything. It could be the number of patients coming in. It could be number of deaths in that particular ward. It could be number of childbirths in the ward, etc. So the axis title or the independent variable does not, the dependent variable, they have not expressed the title. So I do not know what are they measuring. I can understand that these are the ward numbers 106, 107, 108, etc. And this is day, evening and night. But I do not know what is the y-axis. So the title is missing, axis title. Overall, what are they trying to understand from this graph? Chart title is not clearly mentioned. And this legend, look at the legend, it says day, evening and night, which is already mentioned in the z-axis. So this legend is actually useless. I don't need this particular legend. The legend is supposed to convey an information that is not already conveyed in here. Correct? Look at this graph. What are the errors or what are the mistakes? Yes, the title, the axis titles are given very clearly, but I do not have a chart title, that is for sure. Additionally, I have several data points which I cannot view. So beyond this yellow or the green, there is a red one that is going through, red and orange, which I cannot visualize. So I do not know what does that data points look like, whether that is high, whether it is as equal or as tall as yellow, or is it less than green, I don't know. So visualization is a problem in this particular graph. Similarly, again, can you see that in the first category, I'm not able to see all the variables or all the data points in that particular category? That is a problem. However, in this category, I can see pretty much all the categories except the first one in the spring. I cannot see the data points. Next comes the types of graph. What are the different types of graph? First is a pie graph. That is already you are familiar with it. This is usually it represents proportional distribution of any data, and the total of that data has to come to 100%. And one thumb rule about pie chart, that it has only one axis. There are no multiple axes. For representation, of course, you can use 3D pie chart, 2D pie chart, or sliced out. You have different variations of pie chart, but pie chart usually represent one data series and one axis only. It does not have multiple axes. It has labels and one series. This is one series of data, meaning always the total of the pie chart comes to 100%. And how is that 100% distributed among various members or various categories or various data series, various data points? You can see here Hispanic, white, African American. This is the different categories of the population, and this is represented here as how many participants from each ethnicity has taken part in this particular study. 35% of them are white, 9.3% of them are African Americans, 45% of Hispanic origins, etc. So this is a single axis. There is no multiple axis to it, and it is usually a single data series with labels. Next comes the open, high, low, close chart. Open, high, low, close chart. You can also call it as OHLC chart, which is usually also called as a bar chart. But a bar chart usually has the axis starts from the x-axis. It starts from the base to go up. So it cannot be an ideal bar chart, but the data is usually fluctuating data. This can be usually seen in stock markets, where you have the fluctuation of that particular value of the company during that day, during the last 1 hour, during the last 2 days, last 1 week, etc. You can see the fluctuation of that data using a bar representation, but the bar is not fixated or rooted to the axis. It is a floating bar. Then you have a radar chart. Radar chart is useful when you are trying to compare multiple variables of a single constant independent variable. For example, let's say you are trying to measure all the dependent variables of the independent variable. For example, I am Lokesh. Lokesh is a name, so it definitely comes under the independent variable. So that independent variable, I am measuring my height, my weight, my let's say body mass index, BMI, my body metabolism rate, BMR. All of this you are trying to represent in one graph. So if you are trying to represent multiple dependent variables of one independent variable, then it can be done very nicely in the radar chart. So look at this. This is a gymnastic scoring. Gymnastic participant has performed the sequence, and they are trying to give points for the particular performance out of 10. So each of this color, blue color, green color and red color, 3 different participants. Look at that. First, blue color is the first participant. He did very well in the execution of the dance performance. He scored 9 out of 10. But he did very poorly in landing. He could not land it very well, or he could not finish the landing properly. So he got only 5 out of 10. How about the style? His style was very good. He got 8 out of 10. And his creativity was bad. It was only 5 out of 10. And out of all, the difficulty of the moves that he did is very, very less. Like, it's very easy steps he has used. So it is 1 out of 10. This is for blue, who is a person, that is one individual independent variable, and all of this are dependent variable. Let's say to the person who is in the green color, his execution was not so good, it was 6 out of 10. His landing is 10 out of 10, he did a perfect landing. His style was only about 6 out of 10. His creativity is 9 out of 10 and his difficulty is 9 out of 10. Same like that, red person had an excellent, very good difficulty. He had a very low execution style. He had very low landing style or landing stance. And he had okay or a good style, like execution style is really good, or the style of the overall performance is good, and his creativity is also okay. But overall, I think green is definitely dominating. When you total up all this, green is definitely dominating. So this is one way of representing data. If you have one independent variable and you have multiple dependent variable. So when you have one independent variable and two dependent variable, it's easy to go for a 3D chart, that is with X, Y and Z axis. But in this case, you have all of them are one axis, it's a single axis, but it is represented in a radar form which can represent multiple dependent variable of a single independent variable. Next comes the heat map. As I said before, heat map basically means the reason why it's called as a heat map is depending on the intensity or the temperature of the fire, the color of the fire will be very different. A very strong fire will be actually burning in bluish color. A very light fire will be yellowish color, and a slightly medium fire or a medium color will be in red. So you have yellow, red and blue, dark, like very high flame will be in bluish color. So these are the three different, that is depending completely on the temperature that is produced by the fire. So same like that, heat map means the dependent variable, which is nothing but the color of the data point, is decided or represented in form of a intensity of the color. In this particular graph that you are seeing, red is the color that is given for the dependent variable, but the dependent variable's color is decided whether it is 0 is light red or almost pale red, and if the value is above 6000 or close to 6000, it is the dark red, like almost dark, it's a brown color. The red has become brown. So the heat map has a light pale pink to almost baby red to brown. That is the difference. That's the range that they are giving color. And what are the different axes you have here? You have two independent variables. One, name of the place, name of the state, and you have year of the state. And what is the third variable? Third variable is your population. Let's say that is population. So they are trying to measure how many people were staying in that particular country or particular state at that particular year. Then you can use this color to understand. So from the looks of it, immediately you can say the highest population was in 2016 in Brooklyn. The second highest was in 2017 again in Brooklyn, and third was in 2015 again in Brooklyn. So majorly the maximum number of population were taking part in from Brooklyn only in the 3 years. So this is how you easily read a heat map. This is another heat map where you can represent the population in the geographic map directly. For example, let's say these are the population of scheduled tribe people, or the number of scheduled tribe population in different states of India. So look at this color code. This is heat map. If there is none, that means white color. If there are less than 10%, then they are green. That state is colored as green. If they are 10 to 30% domination, then they are called as they are colored as yellow. And if there is more than 30% of scheduled tribes, then it is colored as red. So immediately what you can see is Punjab and Haryana have 0% of or no scheduled tribe population, whereas on the other end you have Chandigarh, which is having more than 30% of scheduled tribe population, followed by Nagaland, Arunachal Pradesh and Tripura, where there are more than 30% of scheduled tribe. So this is the easiest way of reading some variable where the heat map is always the color is represented for a dependent variable and it is expressed over an independent variable. In this case, independent variable is your state. Which state of the country is an independent variable, and the population percentage of such scheduled tribe people is the dependent variable. I'm sure you are familiar with line graph, where you plot all the data points and you connect it in one go. But look at this particular graph. This usually instruments like ECG, instruments like chromatography, they produce a bar diagram, they produce a lines in the graph, X and Y graph. Any graph you see in hospitals which has a line, that will by default come under the line diagram. In hospitals, in instruments like HPLC, liquid chromatography, like in ECG, that's I already mentioned, you can see that the lines are coming. The lines are nothing but connection of data points. For example, let's say I will plot a y-axis and a x-axis. You are having multiple data points. You are recording these data points. These are data points, and when you connect the data points, it becomes a line diagram. So usually the data points are goes like this, where you connect it and you extrapolate the line here. But this kind of instruments, they use line diagram to represent the continuous data. Continuous data again means it's also called as dynamic data, continuous and keeps on changing. So the changes are easier to monitor when they are connected in lines. This is dot plot, where there are too many number of data points that needs to be represented, and it can be easily categorized into groups. For example, look at this. This particular point is this particular graph represents the assay of how many types of cells were present in a given blood sample. So look at this. It says that if the particular cell has forward light scatter this much and a side scatter this much, then it belongs to a particular group type of cell. Granulocytes, monocytes, lymphocytes or lymphoblasts, and debris. And look at this, each dot points in this graph are one data point, that is an X and a Y axis. So you have let's say this particular point, it has 700 forward light scatter and 210 side scatter, or let's say 100 side scatter. So that is considered as one dot point, where it usually has a X axis and a Y axis value, but it is represented by a single dot in the sheet. Same here, you can see blue color and the red color. That helps to understand the groups of the data, but each data point is nothing but a X and a Y category. So next time when you get a new X and Y, you can immediately predict whether it is falling under the blue color or in the red color. In this case, whether it falls under the red color, green color, or the pink color, depending on which you can say which type of cells it is. This is an example of dot plot. So this is for the types of data and how to understand or read a data. So let me show you